Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's challenging level puzzle. And it's called Tables for the Knights by Ridwan. Um, are these Knights of the Round Table? Or Round Tables, I guess? I don't know. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have cells separated by a knight's move in chess cannot contain the same digit. So in addition to having no repeats in any row, column, and box, for example, this cell cannot be repeated in any row, column, or box because we have to have the digits 1 through 9 once each in every row, column, and box. They also cannot be repeated if it's a knight's move away. So these are the additional cells that are a knight's move away from this cell. So this cell cannot have the same digit in any of these cells here. Okay. A circle digit indicates exactly how many circles contain that digit. So, for example, if we had a 6 here, then we would have to have 6 sixes in circles. So we could have like a 6 there, a 6 there, a 6 there, 6 here, a 6 there, and a 6 there. And this would be then valid if there were no more 6s in circles, because we'd have 6 sixes in circles. Because a circle digit indicates how many circles contain that digit. So if 6 is in a circle, there must be 6 circles with a 6 in it. If there's 7s in a circle, there must appear 7 sevens in circles. And that's an example of how these circle digits work. Finally, we have digits joined by a white dot are consecutive, and not all dots are given. So, if this was a 6 here, this would have to be 5 or 7 to be consecutive with it. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first of all, let's count how many circles we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 15, plus 5 is 20, 24, 27, 30, and 31. Which means the digits in circles must add up to 31. Let's count again going from columns. We have 3, 6, 9, 12, 14, 18, 22, 26, and 31. With plus 26 plus 5 is 31. So the digits in the circles must add up to 31. In addition, we know there must be at least 6 of those unique digits because we have 6 digits in box 3, which are in circles. So the digits outside of circles have to add to 14. We can't be missing just one digit. We have to be missing at least... We have to be missing at least 3 digits. Or sorry, at most 3 digits. We have to be missing at least 2. So we're missing 2 or 3 digits adding up to 14. So if it's 2 digits, we're missing either 5, 9, or 6, 8. If it's 3 digits, it could be a wide variety, so that doesn't really help too much. 9 is potentially possible to be in a circle. If 9s are in circles, that means every 9 must be in a circle. So if there's only one digit in a circle in a row, column, or box, that must be a 9. So row 9 satisfies that, so this would be 9 if that's the case. 9 can't be here anymore, and can't be here, so 9 would have to be one of these two digits, and then one of these two digits for row 8 and 7. But this cell sees both of these cells, right? So this cell sees both of these cells. Therefore, if this is 9, neither of these could be 9. If this is 9, that sees that cell by being in the same row, and this cell by knight's move cannot be 9. So this cell, if that were 9, sees both of these cells. So 9, we know, cannot be in circles. Okay. Which means 8 has to be in circles. So we're missing the digits a 9 and then digits adding up to 5. It could be 5 by itself, or 1 and 4, or 2 and 3. But 8 is guaranteed to have to be in a circle. Well, we know these digits, if you have a digit here, it cannot be in any circle in the digit in box 8. Because this cell sees these cells by anti-knight and by normal Sudoku. Same with this one. This one sees this cell by normal Sudoku and anti-knight. So 8, if it's 8 has to be in 8 of the boxes in a circle. And if it's in this one, it cannot be in this one. If it's in this one, it cannot be in this one, which means 8 must appear in every other box. So 8 has to be in a circle here. 8 has to be in a circle here. 8 must be in a circle here. 8 has to be in a circle here. 8 must be in a circle here. 8 is in one of these two cells. 8 has to be in a circle. Cannot be here because of 8 in the column here. So 8 has to be in a circle there. 8 is in a circle in one of these. But this cell sees all 3 of these cells, which 8 has to be in a circle for. All 3 of these cells see that cell, so this can't be 8. This by knight's move, and this by normal Sudoku. This see all the cells in box 1 that could be in a circle. So this can't be 8. We have to have 8 in one of these cells here. Where is the 8 then in row 4? Can't be here because it sees all the guaranteed 8s here. And then this has to be the 8 in row 4 because we're missing an 8 either in row 7, row 8, or row 9 because box 7 or box 8 is the one that's missing an 8 from a circle. Every other box must contain an 8 in a circle, so that means the rows 1 through 6 has to have 6 8s in circles there, which is 1 in every row. So this must be 8 here. That eliminates 8 in the rest of the box. 8 can't be here because of anti-knight. 8 can't be here because of anti-knight. Where's the 8 in box 6? It must be one of these two. That eliminates 8 in the rest of this row there. So 8 has to be one of these two cells in row 6. Okay. um, 8 is consecutive with 7 or 9 here. Seven and 6 also must appear 7 and 6 times in circles. Um, um, what are the possibilities for 8? We could have 8 there. That eliminates 8 there, so 8 would be there, which means this couldn't be 8, so 8 would have to be there. Which means this couldn't be 8. And this couldn't be 8, so 8 would have to be there. That eliminates 8 there, so 8 would be there. Which would mean 8 has to be there. This 8 sees all of 3 of these by anti-knight and by that cell there, so that would be 8 then. So that is satisfied there. Hmm. Oh, we have another thing then. So these, we have one of these cells. If we have a digit in this one of these cells, it cannot be here. So 7 can only appear once in out of these two boxes. In row 4, we could have a 7 there, but if there's a 7 there, that would eliminate 7 in all the circles in box 1. So we either have a 7 in row 4, or we have a 7 in box 1. We cannot have both. So 7 then must appear once in one of the circles in box 7 and 8, and either this cell in row 4 or in this box in row 1. It cannot be both. And it has, so therefore, if we have a 7 there, this can't be 7, then that forces 7s in all the other possibilities. Otherwise, if this is 7, 7 cannot be here, which means we are missing a 7 in row 4. And we're missing a 7 in row 7 in 8, which means 7s in the rest of the rows must be in circles. So the either or for 7s, so 7 also has to appear. If we have 7 here, that means 7 cannot be here. So if we have 7 here, box 2 and box 3 has to have a 7 in it, and box 9. If we have, because we don't have a 7 in box 1, we don't have a 7 either in box 7 or box 8, so the rest of the boxes has to contain a 7. So if we have a 7 here, there's none in box 1, there's none either in box 7 or 8, and therefore the rest of the boxes have to contain 7s. If we have don't have if we have a 7 in box 1, that means we cannot have a 7 in row 4 at all, which means we're missing a 7 in a circle in row 4 specifically, which means box 4, box 5, or box 6 cannot contain a 7. We don't know which. So that means we are guaranteed a 7 somewhere in box 9 and somewhere in box 2 and box 3. That's all we know. Okay. Um, what about 6? Do we have anything else that's restrictive? Not particularly, I don't think. Mm. Hmm. Mm. We do know. Okay, so in row 2, 9 has to be obviously one of these cells. 9 has to be one of. Oh. 9 in box 3 has to be one of the non-circle cells. And all 3 of these cells spot this cell here. These 2 by in the same column, this one by anti-knight. So 9 cannot be here, which means this is a 7. So 7 cannot appear in row 4 at all. And it can't be in a circle in box 6. Can't be here because of anti-knight. Can't be here because of anti-knight. Can't be here because of 7 in the column. Can't be here because of anti-knight. No 7 here because of 7 in the column. So this can't be 7, where we need a 7 in box 5 to be in a circle, so it has to be there, which means this can't be 7 there, which means this must be a 7-8 pair remaining in row 6, because we need a 7 in all the circles in in every non-box 7 or 8 now. So 7 has to be one of these 3 digits here. 7 is one of those 3 digits there. That was kind of cool, actually. This can't be 9, because that has to be consecutive with 7 or 8, and this can't be either. This can't be 7 here. Mm. Um, don't really have any restrictions here, per se. Um, this cannot be a 9. If this were 9, then 9 could not be here because 9's in the same row as that, and I can't be here because of anti-9. And this can't be 7 because 7 has to be in a circle here. So this can't ever be 8, which means 8 is guaranteed to be one of these two cells here. So we have a 9 either here or here in column, sorry, in row 2. 8 is guaranteed to be one of those two. This cell sees both of these. This one by anti-knight. This one sees that one by being in the same row. So 8 cannot be there. So we have guaranteed 8 here or here. We have guaranteed 8 here or here. That eliminates 8s in the rest of column 1 or 3, which means in column 2, 8 has to be one of these 3 digits. This can't be 8 because it sees one of these is 8 guaranteed, and it sees both of those by anti-knight. If this were 8 here, that would eliminate 8 as a possibility here, so this would have to be 8. But that 8 would eliminate 8 here, and it would also eliminate 8 here, which means 8 would have to be there and there, but then there would be a knight's move away. So this cannot be 8 there. So either this is 8, which forces that to be 8, or this is 8, which forces that to be 8. This can't be 9 here because one of these is 2 is guaranteed to be a 9. If this were 9... Oh, if this is 9, a 9 cannot appear anywhere in box 2. Because if this were 9, that eliminates 9 from the rest of the row, that eliminates 9 on knight's move away, and the rest would be in a circle, which 9 cannot be. So this can't be 9, which means 9 has to be there. That eliminates 9 there. 9 cannot be either of these or this, so 9 has to be one of these two. That means row 1, 9 has to be one of those 3. 9 can no longer appear here or here because of the anti-knight, so 9 has to appear there. This can't be 9 because of anti-knight, so 9 has to be there in column 7. Nine has to be one of those two digits. That eliminates 9 as a possibility in one of those two digits here. This one sees that cell by normal Sudoku, and that cell by anti-knight. This cell sees this one by normal Sudoku, and that cell by anti-knight. So 9 can't be here, 9 can't be in a circle, 9 can't be here, so 9 is guaranteed to be one of these two digits. That means in row 5, 9 has to be one of these two. And this is 7 or 8, so that's only consecutive with 6 or 9 remaining. Out of the... because we don't have a 7-8 pair already in the box. Okay, 9 is here, which means 9 cannot be here, cannot be here. It could be in any of these quadrants. Oh, 9 in column 6, where is it? Cannot be here because 9 in the here, which eliminates 9 in the anti-knight's move away. Cannot be in a circle, so 9 has to be one of these two. Okay. Hmm. Um, we cannot have a 7 here. If this is 7, that would eliminate 7 from being here or here. And 7 can only be consecutive with 6 or 8. But we know in these boxes, 8 has to be in all the circles except for box 7 and box 8. So then, if this is 7, that would eliminate 7 here, so 7 would have to be here in box 2, but they're only consecutive with a 6 available. But then 6 would not be available in boxes 1 and 2, and 1 out of 7 or 8. Hold up, that might be okay. Let's try that. So then we have 7, 7, that would force 6 and 6. 7 there. That would force 7 there. Hold up. 8 has to be one of those two. So 8 has to be one of these 3 in column 5. So far, that's okay. So 7, 7. Where's 7 there? No 7 there, so 7 has to be there. So one of these two is a 7. And that eliminates 7 from this cell here, so that would be 8, which is consecutive with 9. That would leave 7 there. 8 eliminates 8 here, so that would be 8 there, no 8 there, so that's 8 there, which means 8 has to be there, no 8 there. So 8 would be there, and then 8 would have to be there. This 8 eliminates 8 as a possibility here, here, and here, so 8 has to be there. That would be 8 there. 9 has to be one of these two, so therefore this would be 7. This is looking okay, so 7 would have to be there out of the circles. And that would be 7, 7 in circles. And then 8, 8s in circles. So that actually seems like it works. I guess we should try the other ones then, because these seem unlikely to be possible. So what happens if this is 7? If this is 7, that's 8. This is 7, which is only consecutive with 6, so that's 8 there. 8 eliminates 8 there, so that's 8. That eliminates 8 here. 7's one of those two, so 7 can't be here or here, so 7's there. That eliminates 7 here, so 7's there. Or do we want to start with an 8? Maybe that's better. So what happens if 8 is here? If 8 is here, this becomes 7. That's 6. That makes this 8. So no 8 here. We have to have 8 there. No 8 there. So 8's one of those two, which means this can't be 8. So that's 8 there. That means this can't be 8 here. Seven's one of these two, which means 7's one of those two, which means 7 has to be here. That eliminates 7 there, so 7 is there. 7 cannot be here because of 7 in the row. And then 7 can't be either of these because of this 7 here. So then we don't have 7 7s in circles because of that. Therefore, that doesn't work. So this cannot be 8, which means where is the last 8 in a circle? It must be here. That eliminates 8 in the rest of the row here. So 8 is guaranteed to be one of those two digits. If we had 7 here, what does that mean? That means 7 would have to be here. 7 could not be either of these. 7 would have to be one of those two. Seven's one of those three. That seems okay. This can't be 8 because it sees both possible 8s in column 5 by normal Sudoku and by anti-knight, so this can't be 8, which means 8 has to be there, which means this must be 7 there. That eliminates 8 here, no 7 here. 8 eliminates 8 here, so this must be 8, which again cannot be consecutive with 9, which means 7 has to be there. So where is this? Where the 7's in row 8? It must be in a circle because we have the 2 already outside of circles in box 8 and box 6. So 7 has to be there, which means this can't be 7. That's 8, which is consecutive with 9. That eliminates 8 there, so it's 7. 8 eliminates 8 as a possibility here, and this can't be 7 or 8, which means where is the 8 in box 1? It has to be here. That leaves this as 7, which does mean 7 cannot be either of these cells, and 7 has to be here. And that's consecutive with 6's, because the 8's have to be outside of circles. So that accounts for all the 6's in circles. 6 can't be, because, sorry, 6 is outside of circles. 6 cannot be in a circle in box 7. It's not in a circle in box 1, but not in a circle in box 2. So 6 must be in a circle in the rest of the boxes. So this is 6. That's 6. This can't be 6 because of 6 in the column, so 6 is there. It must be there. 6 can't be here because of 6 in the column. 6 can't be here because of anti-knight. So 6 has to be there, which makes that an 8. We have 8. No, we don't have 8 6's. In box 7, 6 cannot be here or here because of 6's in the column. Can't be here or here because of 6's in the row. So 6 has to be there. This can't be 7 because of 7 in the row. So 7, the remaining 7 has to be there. We have 8 6's. The last 6 has to be there. And that accounts for all the 6's. How many boxes now do not have circle available? We have box 7, box 9, box 5. How about rows? Row 8, row 9, row 4. Columns? Column 1. Let's just column 1. Okay. So we don't know what other digits we're missing. It could be, again, missing a 5, a 1 or 4, or 2 or 3. Remaining digits of... Oh, 8 eliminates 8 here, so the last 8 in a circle must be there, which means this can't be 8, so 8 is there. Okay, so that's all the 8s. 9... This can't be 9 because of anti-knight, neither can that. So 9 has to be here and here. 9 eliminates 9 here. So one of these two is a 9. Where is 9 in box 7? Can't be here because of 9 in the column. Can't be here because of 9 in the row. This can't be 9 because 9 can only be consecutive with 8, which we already have in the box. So 9 has to be either here or here. Okay. Um, uh, in row 2, the rest, every digit is in a circle except for 1, which means we only have one other digit possible not in a circle. So it has to be 5. That's not in a circle. So this must be 5 here, which means the remaining digits in this row are 1 through 4. So we're missing 5 at all in circles. So in box 3, 5 has to be one of those 2 digits. In box 2, 5 has to be one of these 3 digits. 5 can't be here. 5 has to be one of these 2, because 5 cannot be here because of anti-knight. This 5 sees both of these cells and this 5 here by anti-knight, so this cannot be 5 here, which means 5 has to be here, which is consecutive with 4. That eliminates 4 in the rest of this row. 5 eliminates 5 here and here. So where's the 5 in box 2? It must be there. 1 is guaranteed in one of these cells in a circle in row 2. That eliminates 1 ever being in a circle in any other box, besides either box 2 or box 3. So 1 has to be one of these digits. 5 has to be one of these 3 digits. 1 cannot be in the circle here, so it's either one of those 4 or that cell there. 4 has to be one of these 2 digits here. And this is 1, 2, 3, 4. This has to be 1, 2, 3 as possibilities there. This cannot be 1, because then that guarantees 2 1s in circles. So that's 2 or 3. Um, 5 cannot be here because of 5 in the column. Can't be here because of anti-knight, so 5 has to be one of these 2 digits, which leaves 5 remaining in column 6 in the non-circles. Where is the 5 in row 5? Cannot be here because they are circles. Can't be here because of 5 in the column. Anti-knight in the circle here. Can't be here because of it's filled with a 9. Can't be here because it's in a circle, so 5 has to be there. That means 5 has to be one of these 2 digits here in column 2. Okay. 5 can't be here. 5 can be any of these 4 here. That's fine. The digit that's here has to be one of these 2 digits there. That doesn't tell us too much. The digit here has to be one of these 2 digits here. We need 4 4s. So this can't be a 4 here because of 4 in the column. 1 out of these 2 can be 4. And we only have 4 availables here and here anymore. So this must be 4 here, which eliminates 4 in the rest of the row. This must be 4 here, because we don't have any other place, because we have 1 4 here, 1 4 here, 1 4 here, and only one of these is a 4. But one of them does have to be a 4. So this cannot be 4 here, which means this is 1, 2, or 3. We have 1 through 4 there, 1 through 4 there. Can't be 1 because of 1. We already have a 1 in a circle in row 2. So 1 has to be one of these 2 here. Okay. This can't be 4 because of anti-knight from that 4, so that leaves 4 as that digit there. which means we have all the 4s in 4, so this has one of these two has to be a 4. 4 cannot be here, so in box 4 has to be one of those two, which means 4 cannot be here. 4 is on next to the white crop key dot, and it can't be consecutive with 5, so this must be a 3-4 pair here. Okay. So this has to be 2 or 3. Cannot be 1 because we have a guaranteed 1 here. This must be 4 left. And so what are the digits? This digit can't be either of these, so it must be the same as that. This digit cannot be here, so it must be the same as one of these two. So we have one of those two. That means wherever digit is one of these two has to go here. So that's the 2 or 3. It cannot be 1. Orange then has to be one of these 2, 3. So this dark means this can't be dark here. We don't know which one of these 2 3s it is. But these are not the same. And this 3-4 pair eliminates 3 and 4 here. So this must be 2 as the dark, which means this is 2. So no more 2 here. One of these is 2, so this can't be 2 here. It's 1 or 3. So all the 2s are already in circles. We have 1 here and 1 here. So this cannot be 2. It's 3. This can't be 2. It's 3. So that satisfies that. So this can't be 3 anymore because of 3 in the row. This is 1, 2 as a pair. That eliminates 1, 2 in the rest of the box, so we are left with just 3, 4, and 5 left. This is 3 or 4. This can't be 4 and 4 because of 4 in the column, so 4 has to be here. 3 eliminates 3 here, so it's 5, which makes that 3. 5 can't be here anymore because of 5 in the row. That leaves this as 1 or 2. 5 eliminates 5 here. So this becomes a 5-9 pair here in column 6. Oops. So that leaves that 5-9. This has to be then 1, 2, or 3. This can't be 3 because of the anti-knight 3 in the column. So where is the 3 in column 6? It must be one of these two, so this cannot be 3 here. We are left with a 1, 2 pair in column 4, so this can't be 1 or 2. It's 3. 4 eliminates 4 here, so 4 in this box must be here. That leaves us as 1, 2 as a pair. 2 is here. Remaining digits of column 1 are 1 and 9. This can't be 1, 2, can't be 3 because of 3 anti-knights in the column. So this is 1 or 2, which leaves the remaining digit in column 3 as a 3. And that means this has to be a 1-9 pair here. This can't be 1 or 2 because of a 1, 2 pair in the row, so this is 5 or 9. Cannot be 9 because of 9 in the row, so that leaves this as 5. That means this can't be 5 here. No 5 is remaining here. This could be 1, 2, or 9. No 9. Okay, so let's remove the coloring here, and let's start coloring the 1, 2 pairs. We'll make it green and pink here. So green is knights move from that, so this can't be green. This must be pink, which makes that green. Green eliminates green there, so that's pink. Pink eliminates pink there, so that's green, which makes that pink. So green goes down, so green has to go there. That's 1, 2. This is 1, 2, or 5. 2 cannot be here because of 2 in the column. 4 cannot be here. We're left with 3. 3 remaining in column 8 cannot be here because of 3 in the row, so 3 has to be there. No more 3 here because of 3 in the column. 3 eliminates 3 here. So that means this is a 1-2 pair. That must be not 1 or 2, so that's 3 there. 2 eliminates 2 here, so it's 1. No 1 here, so that must be 3. That leaves that as 2. And 2 is a nice move away from green, so the green cannot be 2, it's 1. The pinks have to be 2 then. 1 eliminates 1 there, so it's 2 and 1. Okay, 2 can't be here because of 2 in the row. 1 eliminates 1 here, so it's 5, which makes that 2. 5 eliminates 5 here, so this must be 5 there. 1 has to be... cannot be here because of 1 in the row, so 1 has to be there, which makes that 4. 4 eliminates 4 here, so it's 3 and 4. 1 eliminates 1 here, so it's 9 and 1. 1 eliminates 1 here, so that's 9 and 1. And 9 eliminates 9 here, so it's 5 and 9. And that's the solution. Yep, challenging sounds about right. I'm very used to these circles, so for me, it's not too bad. But I could see people getting stuck on some of these things. And then I'm not good with anti-knights, but I was able to spot these patterns here and this pattern here, which was essentially the break-in. And then this pattern here. But that took me a little longer because I'm really bad with anti-knight rule sets. But I was able to spot this fortunately, so that made things a lot easier. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.